right, here's another example using FEA to confirm, hopefully, the results of a curved beam analysis. So in this case, this is a problem. I've already done a video for that worked through the hand calculations of this. In this case, we were looking to find a force from a stress, but let's try to go the other way. Let's say that we know the force, and let's see if we get the 30 KSI as the result. So here is blah, 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 all my work, 415 pounds. Let's just use that and apply it. And so we will build this thing in SolidWorks simulation. All right, so here is the previous one that I just got done doing. And so let's start with a new part. And this is going to be in US units. So we'll go into inches. Boom. And let's see, it looks like it's got a T cross section to it. Let's see, go back down to here. T cross section. Let's see, what should we build first and where do we start? I think I'm going to start up here. You know, it's a little bit of a weird one because I don't know if I want to do a so we're going to do the stress like right over here. So I don't know if I want to do a sweep. If a sweep is going to be the thing that's going to work the best. If I were, I would probably make it on this inside surface. I'm going to try that first, but I'm a little nervous that it's not going to model correctly for what I want. So I'm going to go for the top plane, come from over here, and let me think about how I want to do this. I think I will make this right here. Yeah, I'll just do this first. There's probably a bunch of different ways to make this thing quicker. I think that'll be right. All right, so first off, I'm going to move this thing over to here. The midpoint, boom. Oh, look how I screwed up again. I'll make first. Okay, I'll do a lot of the equals because it's symmetric. That and that will equal each other. Boom. This and this will equal each other. And I guess I'll start adding in values. All right, here is supposed to be 3/4 of an inch. Yeah, 0.75. This distance right here is 3/16. Can I just go 3 divided by 16? Sure, so 0.19. This distance is also 3/16, 3 divided by 16. And I think all I have left is this distance. They gave me this is 13/16, so I'll just go with that. 13/16. But I think what ended up happening is that ends up being a total of an inch, right? Because 3/16 plus 13/16. Yep, sure. So you got it all black, so that means it's all defined. Now we'll switch over to the front sketch and start downwards. I'm going to come down to here, and I don't know how far I'll go, but I'll come over to here, and I think I'm going to have a little bit of a problem here in a second, but I'll have to try to work it out. It's not really, this height's not really going to matter right over here, right? So we're looking at this thing. I mean, it doesn't matter how far up or down that we go. Right here is going to be where the 1 inch goes, and the curvature right there doesn't really matter, so it's not going to really do a whole lot. So we might want to make it accurate to look like the thing, but that's not going to be too big of a deal. One thing I want to kind of do is establish this distance right there. I think I want to make that 1/2 an inch, right? 0.5. And I say that because that looks like it's halfway in between. And I want to do like the little wrap around the thing. So I think I'll measure it out in a bit. So this distance right here is going to be 3 inches from right there. If I use that top, I think. All right, so this is all just modeling onto the thing. So I think I can go here to, oh, where are you at? It could be, actually could be just this one. 3 inches right there. And I don't know what this should be. Let's make it 2 inches. And we'll make this 1.25. And then I'm going to make the curvature probably the 1 inch in both of these. So there's going to be 1 inch. 1. Okay. Let's see, double check that's it right here. See, that's going to be 1 inch, and that's the inside thing. And then, how about here? Just make that 1 inch. This one doesn't matter. All we care about is where the force is going to be. And say, okay. All right, so here's our guideline, and here's our section. So let's see if we can get that extrude. Oh, I gotta cancel out of this, or not cancel, but save out of it. And so that's that. You could already see that section. Let me choose this and see if it'll work. It looks like it works. Okay. Boom. Now, to make sure I get the force exactly in the center, I'm going to add in just a little feature here. It's not really all that much of an important thing, but I'll just, whoops, it went to the center. I was trying to go from the corner to corner, put it up to there, and that doesn't really matter, but I will make that and that collinear, excuse me, that and that collinear. And I will exit the sketch, and we'll just extrude this just a little bit. I guess I'm going to go down. And maybe I'll have to go a little bit more. I'll go 0.25. Boom. Right. And that whole thing right there, that's just so I can put a force and just tag on it, and that'll go to this spot. Now, the stress that I want, is it going to be in the right place? I think so. I think that right there and that right there, those are the stress locations that really going to matter to me. I kind of wanted to do like maybe a thing through that, but I don't think it's going to matter. I think I'm ready. So we go to the, not a motion study, sorry, losing it. Go to simulation study, create a new study, make it a static, and we go through the list. We'll apply, I'll use A36 steel because that's my baby, that's my thing, that's my jam, that's what they could say. So that's my jam. And my fixture is going to be completely fixed again, right up here. Boom. You see I picked out that whole face, that whole area. And then external loads. We're going to go a force. We're going to apply it right there. And that force, it's going to be 500, and we're going to go change, and we don't have to do a direction thing like we did in the other. I guess we didn't have, no, we don't. This is going to be perpendicular to this thing, so we're totally good. And so this force, and you see it's in the correct direction already, is 514.5. Just because that's, we being a little overly cautious here. That's all we need. And now we can do mesh, and we'll just accept the default mesh. Check it out, look at it a little bit. It looks pretty, it's pretty fine. It's not too coarse. So just solve it. Let's see what happens. Run. Boom. All right. We got ourselves von Mises stress, but of course we want US units. We're looking to try to see if we have 30 KSI. So edit definition. I'm going to sit with von Mises stress once again because there's really no shear. So this is going to be like the absolute value. So KSI is one of our choices. And I'd like to have the display look like somebody has their brain on. So we'll make zeros at the minimum. And this says as a maximum of 48, right? So I'll go for 50. I don't know where that is. We didn't predict. We predicted that it would be for 30 KSI based on our analysis, but I don't know. Here I'm going to change the numbers from scientific to floating, and I'm going to give myself one decimal place. I don't really need more than that. And we should be okay because there's 10. This definite should be 10 right here. If it was 12, we would get weird ass numbers, but we should be able to get this right higher. And then the last setting I always change from continuous to discrete, so you can kind of see where the demarcations are in there. So you can kind of see where these stress. Oh, interesting! Right here is where the stresses are, right? Where the highest stresses are located right there. But like I think my calculations were for right here at this location, this spot right there. So that's one of the reasons why we have higher, like we see in red that are higher. Let's take a look and see if my results were correct. Let's see, we want to go list selected. So just right across there. We'll update and see, okay, it's even higher. Yeah. So, but there's a couple things to note here. That's not a uniform distribute. We're kind of assuming with this right here that the stress is the same all the way through the thickness onto the thing, but you can see that that's obviously not true right in there. So that's one aspect that we're deviating from the hand calculations. We have like 30 right there. That's close, but it gets larger right in the center. We also note that we're much larger right in there. We could update from right there. We could just plot, and they'll give all kinds of scatter. But you can kind of see where the largest is going to be. Let's see. One way that we could maybe check out what that is, we could run a diagonal split line or diagonal plane and then split line across it. Right? We could also take a look. I didn't do this right for this problem. I didn't do the other side of it. Remember, this is the premise of this, is that we were trying to find the force so it would be limited. But in doing so, this is where I decided to cut it, like right along there. But maybe we should have cut it along those lines right there. It's an interesting result, kind of showing us that whatever I've done here, which I think is mimicking this other problem. Let's see, what did I say this was? Juvinal, 5th edition. Problem 439. Let's see if I can find that in a textbook. Okay, so I didn't get anything different really. In fact, mine was predicting it would be a force of. Well, let me see. Okay, I can see it. Yeah, I was a little higher at 497. I had 515. So let's try the 497. You could see that they ended up with like 30.9, which is slightly higher than acceptable. But I don't know. That's from the solution manual, from the source book as part of this. So we could try that, but I don't think it's going to make that much of a difference. So it was 497. So we can edit that definition and go 497 and solve it again. And we have someone talking really loud out in the right there. See, you're not really gonna change all that much, but well, let's take a look. Let's list selected. Maybe. Let's plot. Still right around there, right around 36. So we didn't really solve the problem. But once again, it's assuming a uniform across through the thickness, which is obviously not true. It's larger in the center. We could, by the way, things to do. We could ramp up what the overall mesh is going to be and solve it. They're generally going to make the stress higher. Doesn't really usually make it. I don't think I can't think of an instance where I've seen it where it would make the stress lower. We could update this. You can see that it'll make the curve more refined right in there, but you still had like it's actually a little higher than 36 than it was before. It's not going to be better, but just as a measure of what the curve what it does. Let's see. Let's reset this and mesh it. But then like let me show you amongst the things you could do is create mesh controls. So if you're gonna have a place where you know where the stresses are, make that a lot refined. And you can also change some of these, or you can make them even finer. But let's put those in there and then remesh it with those mesh controls in there, and you'll see that it should really refine the mesh. So they put a lot more elements right along there. And there's a certain amount of controls that you can do. Let's see, it's underneath the mesh controls right here. You can edit mesh controls, and you could change how much it So I quite often, also, let's see, this is the minimum number of elements in a circle. That's interesting. I don't think that might have changed in recent years. Minimum element size. You could usually also you could change what the transition is from one to another. For whatever reason, I'm not seeing that. What does it say here? Element size, minimum element size. How about we go right down there? We go create mesh. You can really screw this up, and so we can see how many there are. Usually, there's a parameter for how many, what the transition is from over there. But now you can just run, and you can, when you go and list selected into here, you can. Oops, it didn't grab a hold of the ones I wanted to. You can. Ooh, wow! You could really see it's gone crazy. I don't even know what that's. Not doing anything along with the parameters. Let's see, update. There you go. You can see how fine that is in the region. So anyway, that's the FEA. And one thing, before we go, let's have animate it so that it can entertain us and make it go slow. It's making that kind of noise. There you go. Another video down.